Okay, let's see if we can get a graph for this thing here. Let's say that D is the depth of water and T is time in hours after a certain o'clock, after midnight. Okay, so we know we're going to have an X and Y axis. That's a good start, let's leave it there. No, okay, so this 3, this is in the form y equals a sine bx plus d, where d is the pivoting point, I guess, of the graph. It's what its central point, what it moves around. So I'm going to label this as the point 3. And as soon as I've got that, I'm just going to draw it in. So a sine graph, remember a sine graph starts at the origin or where it's moved up, and it's just going to go like that, and it keeps on going on forever. And yes, it does go back that way as well, but that's all right. Okay, so this 2 multiplies my value of sine to go up, and then as sine becomes negative, it will go down. So the maximum value of sine is 1, so 2 times 1 is 2, plus 3 is 5. So this top value here is 5, because the most I can go up is 2 plus 3 is 5, or minus 2 plus 3 is 1. So that's the point 1, 3 is in the middle, and 5's up the top. So the 3 and the 2 really define where it oscillates between the maximum, minimum, and central point. The other thing we need to work out is whether it's tight like that or whether it's wide like that, and that's the job of the B. So really what we're wanting is this rule T, which is 2 pi on B, and B here is pi. So my time period is 2 pi on pi, which is just 2. So T is my time period. The time period is the time that it takes to get from through a full cycle. So from here, from the start to the start, must be 2. If that's 2, then that's 1. Then that would be a half, and that would be 3/4. So that gets you some scale on how quickly the tide is going in or out, or what have you. I won't rub that out. That's my working. I don't want to rub my working out. Okay, you saw how easy that was. So there is no need for you to practice that whatsoever.